All right, guys, this is a recording for 10.7, example 5, okay? Projectile motion. Suppose that Jim hits a golf ball with an initial velocity of 150 feet per second, okay? So suppose he hits a golf ball of 150 feet per second at an angle 30 degrees to the horizontal. So that's theta. This is initial velocity. That's going to be subscript 0. A, find parametric equations that describe the position of the ball as a function. So again, parametric equation is going to require x equals and y equals. Okay, so we are going to remind ourselves what x and y are in the projectile motion. X is the initial velocity, which is v subscript 0, times cosine of theta, okay, times t. Then y equals negative 1/2 g times t squared plus the initial velocity times sine of theta. I'm going to put parentheses around here just in case that you know that theta is not involved with t, okay? And then plus h. This h is sometimes there and sometimes it doesn't have to be, depending on where the ball is located, okay? If the ball is on the ground, h is 0. If the ball is up high, then it's going to have a different value for h. So in addition to the equation, we're going to write something out, okay? Right away, we know v sub 0, it's 150 feet per second, okay? We know theta is 30 degrees. Okay. Then we know h is 0 because he is hitting the golf ball from the ground. Okay. If it doesn't say where he is, we're going to assume that he's on the ground. Then remember, I also gave you the gravity as well. Would you agree? The gravity g is in class was either 32 feet per second square or 9.8 meters per second square. Now you are in, let's see, feet, okay? So that means we're going to use this one. All right, now let's plug it in. Find the parametric. That means I have x equals, initial velocity is 150 times cosine, angle is 30 degrees, okay? I'm going to put parentheses around there because, again, t is not involved because I'm going to put t behind it. You have to simplify. X equals 150 times cosine of 30 degrees is, I'll give you a second just to think about it before I write it down. Did you get it? Cosine is rad 3 over 2. Great, let's move on. You need to simplify that. So x equals 150 times rad 3 divided by 2. So that's just going to be 75 rad 3 times t. Okay, this is your horizontal measurement of this golf ball. Now parametric means you also need y. So y equals negative 1/2. G is 32. T, don't know, right? T squared plus initial velocity 150. Okay, times we're gonna have sine, okay, of 30 degrees. Then I'm going to write t behind here, okay. H is, again, we're going to assume the golf ball's on the ground because it doesn't say where it was placed. So we will definitely assume it's on the ground, okay. All right, you don't have to put a 0 for h. I'm putting on there just so you know that h, where did that go, okay. From here, simplify. 1/2 of 32 is going to be negative 16 t squared. Okay, plus 150. Why don't you give me the value for sine of 30 degrees? And that way I can simplify a little bit more. Sine of 30 degrees is, okay, thank you for telling me. Hopefully you said 1/2. This is going to give me y equals negative 16 t squared. Half of 150 is now just a positive 75 t. Whoop, there you go. All right, so we have the parametric equations. Again, parametric equations means you have to have both x and y equals. All right, y'all? B, how long was the golf ball in the air? Okay, how long means that I'm looking for time. Okay, that means I am seeking for time. How long was it in the air? That means I need to use the height, right? So y equals negative 16t squared plus 75t. So how long was it in the air, meaning that I need to find when it started and when it ends, and then I can just calculate the time difference, okay? That means the ball is on the ground when it first starts and when it lands. So I can set the equal to 0. Let's solve for t. I will take out a t because that's what they have in common. So now I have a negative 16t plus 75. Set each one equal to 0. Okay, over here, negative 16t plus 75 equals to 0. That means negative 16t equals negative 75. T is positive 75 over 16. Okay, now so at the beginning of time, that's what this is happening. At the beginning of time, the height is 0. Then t equals to 75 divided by 6. Okay, that's when the ball also is 0. It lands on the ground, so the height is 0. So I just have to, can I reduce that 75 by 16? Nope. So if I use my friendly calculator, and again, don't round until the very, very, very end, okay? Let's round to 2 decimal places, okay? So how long was it in the air? The ball was in the air for about 4.69. What's the unit of measurement? T is, did it say? Did it say it at all? I'm assuming seconds, right? Oh, seconds. Ooh, I was like, wait, I have to say. Okay, seconds, okay? So the ball was in the air for a total of 4.69 seconds. C, when was the ball at its maximum height? What is the maximum height? Okay, so this has 2 parts. So maximum height, again, we are going to use the y equals. Y is going to talk about the height of the ball at any given time. So again, the y equal is negative 16t squared plus 75t, okay? Now, because this doesn't come out to be nicely in numbers, you may use your calculator. If I were to give you nice numbers, then you can't use your calculator, but it's not very nice. So we're going to use a calculator. Let's see. Where is my internet? All right, let's go to internet. I'm going to use decimals because I do not know how to. I don't have a TI-84 on my Surface Pro. All right, let's find decimal really quickly. Let's plug in the equation. Y equals negative 16x squared plus 75x. All right, let me minimize this. I don't need negative height. I do need to minimize a lot more. Oh my, there it is. Okay, so it's asking, okay, when was the ball at its maximum height? So again, I'm looking for time, but let's find this first, okay? Whoa! Negative height, don't need it. Here we go. I'm going to find this dot. Decimal is great because it just gives you the dot right away, okay? That dot is negative 2.34 and 87.89. Okay, we'll take 2 decimal places. Let's go back to our thingy. Okay, based on the calculator, it says, okay, negative 2, oops, why am I saying negative for? I am so sorry. I meant positive 2.34. Oof, can't read that, right? Comma 87.89. Well, this is really talking about time, right? Because remember, this is a function in terms of time, and this is how high the ball is. So you kind of have your value already, okay? So let's write it down. The ball will reach the max height in 2.34 seconds, okay? So that's one part of the question. And it says, what is the max height? The max height is, let's see, 87.89, and I believe this was in feet, but let me double check. Yep, it's in feet. Okay, so that question right there needs both answers. Okay. D for dog, determine the distance that the ball traveled. Okay, so now this is the part where X is going to come in. Determine the distance that the ball has traveled. So the ball has traveled, meaning I'm not looking for height anymore. I'm looking how far did it go. So I will use my, you're right, X equation. Okay, 75/3 times T. But what is T? What do you do? This is where you plug in where the ball, what time the ball landed, right? Because this right here is the two values. This one is when the ball first started, okay? The time and the height. The height is going to be at 0, okay? And when the height is 0 the second time, it gave me the time of 75/16. No, you should not use 4.69. Always use the non-rounded answer. So that way, when you're rounding it again, you are a little bit closer to the real answer. So this is when I punch it in my calculator. It's going to give me 608.92, okay, feet. So determine the distance of the ball traveled. So the ball has traveled 608.92 feet in total, okay. Then it says using your graphing calculator, and I want you to kind of watch the ball where it's going. This is what we did at the beginning of the class for about 15 minutes, okay? Now try it out, graph your x equals y equal equation, and then if you can't figure it out, come and see me in tutorial and I can help you with the calculator stuff. So on your own, since I cannot graph on my Desmo, okay? And this is the end of our video notes.